Quadratic equations. If you had a quadratic equation that you're used to with just x's, how do you solve them? What were our strategies for solving for x, like we have on the right? Making one side equal to 0, does that ring a bell? Factoring. So this is already equal to 0. Can you factor this? There's a common factor of an x. And then using the powerful thing of when two things are multiplied to equal 0, one of them has to be 0. That's the only way you can multiply two things and get 0. So either the first one, and I'll put a line where the multiplication is, either the first one's 0, well that's easy, x would have to be 0 if the first one were 0. Or the second one is equal to 0, and in that case x would have to be equal to 1. We're going to do the same thing now, just with trig functions. Can you see that there's a cos in common? So we factor out a cos theta, leaving us with cos theta minus 1, and that's still equal to 0. Common mistake when people factor an equation like this is they forget to write the equals 0. This is a warning right now. Every time you do that on every quiz and every test, you will lose a half a mark. If you factor and it was an equals 0 before and you don't write an equals 0 in the next line, that's a half mark deduction every time you do that. So if you'd like to do that 10 times on a quiz or a test, it adds up. Now that it's equal to 0, that's really important. And the reason it's really important is because that means either the first one is equal to 0, in which case you'd have cos theta equals 0, or the second one is equal to 0, and there cos theta would equal 1. Now up till this point, everything is exactly the same as if it were an x, like we see on the right. But now we ask ourselves, is the x-coordinate, because cos is your x-coordinate, ever 0 on your pie plate? Yes. Okay. This part of the question says we're looking one full revolution around in the positive direction. When is the x-coordinate 0? Pi over 2 and 3 pi over 2. Is the x-coordinate ever equal to 1? What angles would that be? 0 and 2 pi. One thing I always do when I'm done a question like this is I double check the original domain. Now for all the ones that we're going to be solving right now is going to be between 0 and 2 pi, and they're going to be included. I've seen on exams where they write this. You see the little difference? The second inequality doesn't have the equal sign underneath it. That means 0 is included, but 2 pi wouldn't be. And if you had this second domain, you'd have to erase the 2 pi because it's not included. So always look back at your domain at the end for each one. But for all of these questions that we're going to do, it's going to be between 0 and 2 pi. Here we have another squared one. So the main idea that we had in our head from the first one is make one side equal to 0 and then factor. In cases where you just have the one thing squared, do you know that you could just get that by itself and then square root both sides? So if I were to do that, I'd get sine squared equals 3/4. And then square rooting both sides, will leave me with sine theta here. Now, a square root of fraction means you can do the square root of the top and the square root of the bottom. So square root of the top would stay √3, but square root of 4 becomes 2. That's important because that's one of our values on our pi plate. And right now, if I would keep going, I'd lose a mark because I forgot. Plus or minus. Whenever you take the square root of both sides, you have to remember plus or minus. So now, sine is our y coordinate. Is there ever √3/2 on our pi plate? Yes. What family? Pi/3. And because it's positive and negative, you're looking in all 4 quadrants. So you have pi/3 from quadrant 1, 2 pi/3 from quadrant 2, 4 pi/3 from quadrant 3, and 5 pi/3 from quadrant 4. Call this one a family gathering. Everybody's invited. So this is one, if you just have sine squared or just cos squared, that you can isolate it and you wouldn't have to factor it. But the majority of the ones that we're going to do will look something like this, where you have to factor it. I'm just going to write this with x's temporarily to talk about practicing some factoring skills. First of all, factoring is the opposite of multiplying it out. When you multiply something out, if I had to multiply this out, what do you remember? FOIL, right? You multiply the first ones, the outside ones, the inside ones, and the last ones. And you would get 3x squared minus 1x plus 12x minus 4, right? And the middle two, Ken, this is your first, this is your outside, this is your inside, that's your last. And what always happens when it's made into a trinomial, your first ones still appear from multiplying, that's your 3x squared. Your last ones still appear, but your outside and inside always get combined because they're like terms. Now, we use this same idea when we're factoring it out, okay? A number of you probably have, if you have techniques, like if you use the grouping strategy or stuff like that from last year, that's great if you remember it. But one of the things we're going to do now in grade 12 is we're mainly going to think about factoring being the opposite of FOIL. And key things here, the key hints is we already know what our first ones and our last ones have to multiply to be. For the most part, the factoring ones you get in grade 12 will be easier ones to factor, and you'll be able to do it directly in one step. So for this one, it's actually one of the easiest ones to factor. Because if I look at my first term, which is a 2x squared, there's only one possibility to get that. It has to be 2x and x as my first ones. Does that make sense that that's the only possibility for my first ones? And this one's really easy because our last one is 1. And the only possibility to get 1 is 1 times 1. Now, it could be positive 1 and positive 1, or negative 1 and negative 1. We're going to deal with the signs now at the end. My outside and my inside need to make negative 3x. My outside and my inside need to make negative 3x. Can you see right now I've got an outside at 2x and an inside at 1x. And if they were both negative, my outside would be negative 2x and my inside would be negative x, and putting those together would get negative 3x. And so I'm able to factor that quite easily in one step. I don't have to use a grouping strategy, but I'm just thinking about how FOIL works and working backwards. The same thing happens now that we're dealing all with signs. Put your brackets, make sure you write equals 0. The only possibility to get 2 sine squared is 2 sine and sine. The only way to get 1 would be 1 and 1. And thinking of my outside and my inside, to get a negative 3, these would both have to be negative. What I do every time I factor, even after I've plugged everything in, I quickly FOIL it out again just to make sure that it works. I don't write it out, I just do it in my head. Do my first ones match? Yes. Do my last ones give me positive 1? Yes. Do my outside and inside combine to give me negative 3? Yes. Now I know that I've factored it correctly. Now we can split it up. If the second one were equal to 0, sine theta would have to be 1. If the first one were equal to 0, and eventually you'll be able to write this directly to be sine is 1/2. Temporarily, you might take an extra couple steps to write 2 sine theta minus 1. I want that to equal 0. So I would have to move the 1 over and then divide by 2. And then you would see that it has to be sine theta is equal to 1/2. On our pie plate, sine is 1/2. What family? Pi over 6. It's positive, so we'd be looking in quadrant 1 and quadrant 2. Sine theta equals 1. What angle would that be? 90 degrees, or pi over 2. And we're done.